number 10. It says each of the numbers from 1 to 20 is written on a slip of paper and put in a bag. If two of the slips of paper are chosen without replacement, determine the probability that, and there's a bunch of questions. Alright. What's the probability that both numbers are odd? So that's going to be the probability of an odd and another odd. And how do I find that? I multiply the probability of an odd on the first selection by the probability of an odd on the second selection. So the numbers from 1 to 20 are broken up. There's 10 evens and there's 10 odds. So the probability of getting an odd on the first selection would be 10 out of 20, or 1/2. And now this is where you got to realize it's without replacement, so I'm not putting that slip back in there. So there's now 19 slips left. And out of those 19 slips, I already took one odd out, so there's only 9 odds left. So this is really 10 out of 20 times 9 out of 19, which would be 90 out of 380. Or you could reduce that to 9 out of 38. So that would be the probability of getting both odds. Now the probability that both numbers are greater than 12 is going to be the probability of a number greater than 12, that's supposed to be a greater than symbol, times the probability of getting another number greater than 12. So how many numbers are greater than 12 that are from 1 to 20? Well, it's 13 through 20. And if I take 13 through 20, that's actually 8 out of the 20. And then if I've taken one of those 8 out, there's now only 7 of those left out of the 19 numbers that remain. So this probability would actually be 56 out of 380. Right? So you could reduce it to 28 out of 95. And then C says, well, what's the probability that the first is less than 7 and the second is over 15? So this would be the probability that you get a number less than 7 on the first try times the probability that you get a number greater than 15 on the second try. So how many of the numbers are less than 7? Well, it's just 1 through 6, so there's 6 out of the 20. And how many of the numbers are greater than 15 now? Well, there's 5 numbers that are greater than 15, and I didn't take out one of those the first time, right? I took out one that was less than 7. So there's still 5 numbers that are greater than 15, but now there's only 19 numbers altogether. So it would be 6/20 times 5/19, which is going to be 30 out of 380, which would reduce to 3 over 38. Now part D just asks, what is the probability that neither number is less than 5? Now what you probably want to do here is you want to probably rewrite this as the probability of not less than 5 and again not less than 5. So that would be the probability of a number not less than 5 on the first selection times the probability of a number not less than 5 on the second selection. Right? I'd multiply those together. So how many numbers from 1 to 20 are not less than 5? Well, it's everything except 1 through 4. Right? So it's going to be 16 out of 20, because it's basically 5 through 20. And now the second selection, alright, I have 19 numbers left, and out of those 19 numbers, how many of them are left that are not less than 5? Well, I took one of the 16 out that are not less than 5, so now there's only 15 left that are not less than 5. So this would be 16 out of 20 times 15 out of 19, which is 240 out of 380, which would reduce to 24 out of 38, which is really 12/19. So the probability of not getting a number less than 5 on both selections would be 12 out of 19. Now 11, it seems like now we're into these counting principle and permutation and combination problems. So 11 is just really a counting principle problem. The access code for a car security system consists of 4 digits. So you have 4 slots, right? I call this slot and choice. I have 4 slots, 1 for each digit, digit 1, digit 2, digit 3, digit 4. The first cannot be 0 and the last must be even. How many different codes are available? Now, since they didn't say anything about repetition, we'll assume that we can repeat. The only restrictions, however, though, are that the first cannot be a 0. So there's 10 digits normally, but the first digit cannot be a 0. So there's really only 9 choices for the first digit. And the last one has to be even. So how many digits are even? There's actually 5 even digits, right? 0, 2, 4, 6, and 8. And then now for the other 2 slots, right, the second digit and the third digit, there's no restriction. So those can be any of 10 digits. So this would just be 9 times 10 times 10 times 5, which would be equal to 4,500. So there's 4,500 codes available that consist of 4 digits, where the first one can't be 0 and the last one must be even. Alright, and then 12 is a very similar problem. How many different 7-digit telephone numbers are possible if the last digit cannot be a 0 or a 1? Well, again, I have 7 slots, 1 for each digit of the phone number. They don't say anything about repetition, so we'll assume that we can repeat digits here. And for the first one, we can't have a 0 or a 1. So for the first digit, there's only 8 possibilities. But now again, for the remaining 6, there's no restriction. So the remaining 6, I would just have 10 choices for each. And again, this is just a counting principle problem, which tells me that I just multiply all these possible outcomes for each digit. So I have 6 tens, which would be 1 million, and then I would multiply that by 8, so I would get 8 million. Right? There'd be 8 million possible 7-digit phone numbers when the first digit can't be a 0 or a 1. And then 13, again, is the same kind of problem. Security code for a building consists of 6 numbers, so we've got 6 slots. The first digit can't be 0, and repetition is permitted. So the first digit can't be 0, so it could be any of... the first digit cannot be a 9, so it could be any of 9 other possibilities. And then the remaining 5 digits can be any of the 10 possible digits. And there they specifically tell you that repetition is permitted, but in all these problems you would assume that it is permitted unless they specifically state that it's not permitted. So here repetition is permitted. So I just have 10 times 10 times 10 times 10 times 10, so 10 to the 5th times 9. So it would just be a 9 with 5 zeros after it. Right? So that would actually be 900,000. Alright, and so again, I mean, they were very similar problems, 11, 12, and 13. They were very, very similar. Now 14 is asking you, what is the difference between a permutation and a combination? So the bottom line was, with a permutation, order is important. With the combination, order was not important. So in how many ways can you choose 3 people to interview from a pool of 10 candidates for a job? You're just choosing groups of 3 out of 10. So what you're doing is a combination here. Out of 10 people, you're choosing groups of 3. So this would be 10C3, which if you want to do it by hand, it would be 10 times 9 times 8 over 3 times 2 times 1, which is actually 720 over 6, which is 120 possible groups of 3 people. And then in C, you're creating a logo for your company. You need to select a color for a border, a color for the center, and a color for the lettering. From the 10 colors available, in how many ways can you arrange the 3 colors? So I'm assuming here that you can't reuse the colors, because if you had the same colors, you wouldn't be able to tell the difference between the border, the center, and the lettering, I guess. So it's not really clear here, but I'm assuming that you can't repeat the colors. But in this case, the order is important, because which color you choose for the border, which color you choose for the center, and which color you choose for the lettering, it makes a difference. So the order is important here. So this is still, out of 10 objects, you're picking 3, but in this case, it's a permutation, because the order is important, right? Because you're choosing border, center, and lettering. So in this case, you have 10P3, which is actually just 10 times 9 times 8, which is 720. So in this case, there'd be 720 possible arrangements. Alright, so we got 2 more problems here. 15 is choosing cookies for a box, a gift box. So you're choosing 3 cookie types from 5 types of cookies altogether. You've got chocolate chip, oatmeal raisin, sugar, peanut butter, and chocolate. And out of those 5 types of cookies, you're choosing 3 to make this gift box. And what I just said there is the answer, right? Out of 5 types of cookies, you're choosing 3 to make the gift box. And they don't tell you anything about, arranging it, the gift box, in a certain way, like where you have like certain cookies on the outside, some on the inside, or anything. So we're assuming the order isn't important here. So you're really just doing 5C3, which would be 5 times 4 times 3 over 3 times 2 times 1, which is just 60 over 6, which is going to be 10. Alright, and then 16, another problem. In a state lottery, you must select 5 numbers in any order. So again, the order is not important. So that's a giveaway right there, that it's a combination. Out of 40 correctly to win the top prize. How many ways can 5 numbers be chosen from 40 numbers? Again, it's right in the question. I mean, it's really a dead giveaway. How many ways can 5 numbers be chosen from 40 numbers? So out of 40 numbers, you're choosing 5 of them. And what is 40C5? It's 40 times 39 times 38 times 37 times 36 over 5 times 4 times 3 times 2 times 1. And this one I would do on the calculator, and I would just say 40 C5B, 658,008. So this is 658,008. Okay, and then it says you purchase 1 lottery ticket. So what's the probability of winning with 1 lottery ticket? It's just 1 out of all the possible winning numbers. So 1 out of 658,008.